Hi class, this is Professor Teixeira. In this video, I'm going to show you how to manage an economic production quantity problem and come up with inventory management policies for economic production quantity types of problems, also known as EPQ. In the EPQ type of problem, what's happening is the company is producing products for their own inventory, but part of this production is already being consumed. So the company produces, and then part of that production goes directly into consumption. So the company never reaches like the stock up, never stock up because is consuming part of the inventory. Okay, so that type of model takes into account that consumption, and that's what it happens. Okay, so let's take a look here. Let me show an example. For example, here we have AGP uses 6 printed circuit boards PCB per day. They produce 20 PCBs and produce PCBs in batches of 200 units. So if they produce 20 PCBs per day, it's going to take 10 days to produce them, all these batches, all this batch. However, they produce 20 PCBs per day, but they consume 6. So what goes really inventory is 14, which is the difference between 20 minus the daily consumption of 6. Okay, so the formula that we're gonna have now is this maximum inventory. This maximum inventory is the quantity, the optimal quantity here, multiplied by the 1 minus the ratio of the demand and production. So the production is always bigger, demand is lower. So what's the percentage of this demand is being consumed from production? And then what the remaining is what keeps in inventory. Okay, so let's take a look. So here is again, you see the total annual cost is the cost to place orders and the holding cost, which in this case is going to be a maximum inventory, which is not similar as the EOQ problem. The maximum inventory, as I just said, is a function of the ratio between daily demand and daily production. And our Q, our optimal order quantity, is given by this formula, which takes into account this ratio between daily production and daily consumption. Let's take a look at the problem and solve it. Let me pull up an Excel file here. Let me open an Excel. Excel, please. Okay, so let's do it here. Ashley's Beach Chairs Company produces upscale beach chairs. Annual demand for chairs is estimated at 18,000 units. So that's my capital letter D, 18,000 units per year. My keyboard is kind of slow today. Okay. Oh, all right, let's keep moving. The frames are made in batches before the final assembly process. Ashley's final assembly department demands frames at a rate of 1,500 per month. So that's my lowercase d, 1,500 units per month. You see, I type, it takes some time for Excel to, you see, I don't know why there is this delay. Units per, I'm sorry, guys, units per, what's going on here? Why is not working? Units. Okay, let's move on. Units per month. Ashley's frame department produces 2,500. So the daily production or monthly production is 2,500. Is it maybe the battery that is dying? 2,500, come on. 2,500. It's per month. Oh, it's working out per month. Okay. So the setup cost is the cost to set up. How much is the cost of setup? $800. $800 for setup dollars per setup, which is similar as to place orders. And the annual holding cost is $18 per unit. So my age is $18 per unit. What else I have in information here? The company operates 20 days per month. Month is 20 days. And the lead time is 5 days. Lead time is 5 days. So, all right, so let's do it. So let's do my daily demand here. My daily demand is gonna be my monthly demand divided by the number of days I operate each month. Daily demand divided by the number of days, 70 units per day, okay? And why I'm doing that is just because the lead time is in days, okay? And they are telling us that it's 20 days per month. So I might need the daily demand in the same unit as the lead time days, okay? All right, let's do it. Determine the optimal order quantity. The optimal order quantity is this. Let's do it. EOQ, we are going to have my numerator and my denominator. Let's do it. It's 2SD divided by 2SD divided by age multiply. Gonna be age times 1 minus the ratio of demand and production. Okay, so let's do it. This is first denominator 2 times my setup cost times my annual demand divided by, open parenthesis, my holding cost times 1 minus, open parenthesis again, my daily, my monthly production divided my monthly demand divided by monthly production. Close 2 times this parenthesis. One more time here. Is it right? Yeah, let me see. Yes, I did it. Now the square root. I take the square root of this number, which is this equal as Q or T function. So this is my Q. This is Q. Optimal order quantity is 2,000 units. Okay. What else they're asking here? So the total annual cost. Let's see the total annual cost. Okay, let's do by parts. Let's do first total order cost. Total order cost is the same as the OQ formula, annual demand. There's going to be annual demand divided by Q times 2, now times S, the cost to place orders. So that's going to be equal to, open parenthesis, my annual demand divided by my optimal quantity times the cost to set up, then my total holding cost is gonna be equal to my I max. Okay, my I max is Q times this quantity times age divided by 2 times age. So I'm gonna first compute the I max. So let me compute I max first. So my I max here is going to be equal to this. I'm gonna implement this in here in Excel. So it's equal to my optimal order quantity times 1 minus, open parenthesis again, my ratio, demand and production, close parenthesis. That's my maximum inventory, okay? This is my maximum. Let me put here. This is my maximum inventory. Is my maximum inventory because even if I produce 2000, my optimal order quantity is 2000. I produce or I order 2000 units every time. I'm consuming part of this inventory, okay, and then never reach the maximum. All right, total holding cost depends on the IMAX. The IMAX divided by 2 times age. So it's going to be IMAX divided by 2 times age. That's the final formula. So let me open parentheses. This guy divided by 2 times my holding cost of $18. You see, same numbers, 7,200, 7,200 is designed to be like that. Both have to be the same because both minimize the order and holding cost. So finally, my total annual cost without the purchasing cost, remember, okay, is going to be equal to this plus this, $14,400, okay? And finally, the reorder point. The reorder point is going to be the same as before, right? So my reorder point here is reorder point is my, in this case, daily demand times my lead time. So my daily demand here is 75. My lead time is 5 days, both in the same units. So 375 units. Again, I ordered 2000 units. When my inventory, which never gets to 2000, the maximum gets is 800. When it goes down, I'm consuming, I'm using. When it reaches 375 units, I start a new order for production or for a new order from my suppliers. Okay, let's take a look here. What they have as answers: 2000 MyQ, 800 units, IMAX, 14,400 is the total annual cost, and the reorder point is 375 units. Okay, all the same numbers, beautiful, right? Okay. And that's it. Here there is another problem. Let me see if we can do that very quickly now that my keyboard is back working. Let's do this just to like see how the different flavors this problem can come. Jackpacks manufactures backpacks made from microfabrics. The cutting department prepares the material for use by the stitching department. So we have a process: cutting first, producing for stitching. Okay, the cutting department can cut enough materials to make 200 backpacks per day. So we have a production per day here. I like to centralize. It's 200 units per day. Okay. The backpack stitching, which receives these backpacks, produces 90 backpack per day. So their demand is 90. They produce 90, they need 90. Okay? So that's our D. 90 units per day. You see, these guys are producing in a given rate. These guys are consuming a different rate. If we quickly do here, D divided by P equal D divided by P, it's consuming at a rate of 0.45 units, okay, of backpack. So if you multiply 0.545 units, that's what is the remaining is what is goes to inventory. Okay, for example, if we do this times this, goes only 90 to inventory. All right, so yeah, let's go. factoring the remaining goes to inventory. That's what is consuming. 0.45 is what is consuming. I'm at my mistake here. The back, okay. Annual demand for the product. Annual demand for the product is 22,500 units, 22,500 units per year. Yeah, the company operates 250 days per year. The year has 250 days. So I can compute my daily demand, because if the problem is telling the annual demand and the number of days per year, my daily demand is going to be equal my annual demand divided by number of days. That's my daily demand, daily units per day. Daily demand is units per day, 90 backpacks per day. Estimate setup cost is 60. So my setup cost is 60. Cost dollars per setup. My holding cost is $6 per unit. Dollars per unit. Okay, that's all right. Calculate the economic production quantity for the cutting department. So we have to compute the economic or the quantity for the cutting department, how many they have to produce every time they produce. Remember, this is, I don't remember anymore. So this is 2 ds divided by, so this is 2 ds divided by h times 1 minus d and p. Okay, so let's implement, that's the square root of this number, of course. So first let's do 2 times my annual demand times my setup cost divided by open parenthesis my h times open parenthesis 1 minus open parenthesis again. I could get this ratio, but I'm gonna do it again. D divided by P. Okay, close parenthesis 1, 2, 3 times. That's a very ugly number. Then we take the square root of this number. That's the square root. 900, that's much better. 904 units. That's Q, optimal order quantity. Okay, let's see where is the problem. Here is the problem. Okay, blah blah blah. We computed total annual cost. Remember, we have the total order cost, which is my annual demand divided by my optimal order quantity times cost to set up. So I'm going to do first my annual demand divided by the units I produce every time I produce or order something times the cost to set up. 1,492. Now my total holding cost. Remember, let's compute the IMAX first. My IMAX is here, Q. It's gonna be equal to my Q times 1 minus the ratio of D and P. Okay, so my maximum inventory is 497 units. Now I can compute my holding cost, which is IMAX divided by 2. IMAX divided by 2 times H. Okay, so I'm gonna do this guy divided by 2 times the holding cost. Beautiful, look at that. That's two numbers are the same as they are supposed, that they're designed to be. They're minimizing the cost. So my total annual cost, no purchasing cost here, just to clarify, it's going to be equal to my ordered cost plus my holding cost. That's $2,984. All right, let's see if there is no. That's it. That's the question. Okay. That's it for EP, EPQ.